I'm trying to make a swing arm suspension called the Dust Devil. If you saw in my first video, I did a preliminary test at ATM. I've just been through doing some of the VSB testing and stuff, and if you saw in my first video, I mentioned that the bump load test is at 4G, which is quite a large bump, and seeing the results on the ATM. I've done a few little improvements to it, but I sort of just wanted to show the results here because it performed really well. So if you're trying to do any designs like this, I'll show you some of the little things I've done. Remember too, this will all be on Patreon so you can get it yourself. So here's the actual design. You can see it's a little bit different from the first video. Having a look around it here, the main thing you can see are these gussets on the bottom here now. These two larger ones. I've done that to absorb some of the flex in the arm. You still got our gussets down the bottom there. You can see on the knuckle, I did end up extending that through to absorb the impact on the end of the fin. And that works really well, actually. A good way to disperse a bit of force. I didn't want to put a fold on the bottom of that piece because it was a very thick piece of steel, so easier to just laser cut. I added this tab here because I always saw a lot of force, and you'll see that this tab has worked really well too. Any dicky geometry and stuff like that's been compensated for in bondings, so like that's a fully welded piece, so in the actual bondings and stuff I've got the welds allowed for. So the actual test itself ended up really well. And remember the 4G, 1G is gravity sort of thing, so at ATM the mass is itself at 1G, so at ATM I want 1400 kilo, 1G it's 1400 kilo, and you just times it for each G, so 2G would be 2 times ATM. In this case, so we're going 4G, 4 times ATM, 4 times 1400, 5600 kilo, large test. You can see I've fixed those areas. Here's where the force is applied here. It's going to be applied down to the plate from the spring and to the head of the bump too, because this is obviously it's a bump load, so we want to see those forces as if the spring had compressed and bumped against the bump above it. And you can see the force there, 5600 kgf. And over here you see that corner. I didn't end up doing anything to that. It still absorbs the impact pretty well. So you can see there I just had hinge mates, or hinge fixtures for each one of those, the hinge mountings and the actual bearing. So I'm on MPA, you can see, and I've got my 350 max set because this was 350 grade steel, and this was a 5600 kilo. So you can see there it's performed really well. I'm very, very happy with the results on it. And it passes the test at this rating. So this design has passed the test. You can do things like allow for your shock absorbers. I find that really difficult because I use pressure-based shock absorbers, not spring ones. So it's difficult to find the exact amount of resistance to allow for them. But that just helps also resist a bit of the test and move a bit of the force around and stuff like that. Whereas this is more than good enough, I think. Anyway, anybody out there could prove me wrong. If anybody's worked with swing arms, I'd love to hear what you've got to say about it, because I just try to interpret the standards. So any of the higher forces that we've got here now can easily be seen as force anomalies. I'll get that right. So I'm not worried about them. We don't see any forces that are like or red areas stretching across beams, so like yields that would represent what they look like in real life, like red areas and stuff that span out and look like bends from real life. You can see here that the forces there are there, but it's all being absorbed pretty well by the structure itself. And as I said too, like there's bondings allowed for this, so like the rounds on that rear piece of steel there, you can see that cut, like that there is just a shaping, it's a molding, because that's all one piece of steel, so there's a lot of pressure on that joint, but you can see that it absorbs it pretty well. I think the plate helps a lot with that too. Still force on the outside corner, but it's not a major problem. Doesn't reach into the yielding range. So you can see how those few things, those gussets and stuff like that, really helped this design pass its final testing. This is just the maximum yields showing now. Oh, sorry, the maximum MPAs that we're seeing affecting these members. And you can see there's a higher number there, but I'll show that soon. I think you'd nearly be safe to say that that's like a force anomaly. I think there's better numbers later that we could get a heaps better safety factor off. Like there you go, 240, 237. This is spanning like going down from the highest forces. 233, still out there in that number. 227. You can see the areas there that the highest forces are affecting, like the lower area there, because you can imagine that plate bends and tries to push that external wall in. And out here on this edge, obviously we've still got higher forces. Well, that's where like the main mass essentially is held for it, because the top end's hinged, then there's the wheel and all that force comes down on it. So it does try to bend that area where it's meeting the wheel or meeting the back of the brake drum. I don't put the brake drum or tire or anything like that in these sort of tests. As I said before, they all come with their own ratings and stuff, and I trust their testing. So no need to try to double test stuff. Also, it's harder. So this is much easier. And this is just one assembly. So in the ISO clipping, back down to 0. So we see new force, or we'll just see the basic force. And now as we go upwards, it's going to isolate the forces, so we can see more of like the force anomalies. And here you can see, so, if you were going to safety factor this thing, you could look at this, in the 175, 200 sort of range. You saw 240 as some of the numbers earlier, so you get a decent 1 point something out of the safety factor. It'd be great to get a 2 out of it or something, but you've already got a lot of it. Like 1 is enough in this case because there's a proof load. So instead of safety factor in this case, you've got a 4G proof load, so you don't have to go for that. So there you can see, look, at 245, we saw those forces there earlier, but look, they're non-existent. And you got to zoom like right in here just to try to find the high, the 245. So as I'm really happy with the design. I'd love to hear what an actual engineer doing work on suspensions thinks of that sort of design, but I think it's really good as a trailing arm suspension. It's up for grabs too, and you can use it in your own designs and stuff like that. It will be on Patreon. All the parts, you can have it as just parts, you can have it as an assembly, whatever you want to do with it. The testing stuff, of course, is separate. You can do your own testing if you want to. So that's just Wank, the Dust Devil thing on the side. Could say anything. I just made Dust Devil up. I was just sitting there and thought, I don't know, it's an off-road suspension. Let's give it that sort of name. Okay, that's all, folks. Thanks for watching.